Hey guys, all right, who knows about the Cape May Ferry? Well, today's adventure, we're boarding it, the math magical Cape May Ferry, where multiplication mysteries await us. Our mission, to discover the common ways to record multiplication while still having a blast. Imagine this. You're standing on the top deck of the ferry, wind in your hair. As we cruise along the math seas, let's talk about area models. They're like the treasure maps of multiplication, guiding us through the sea of numbers with ease. Ready to find the mathematical treasure? Now, hold on to your hats, because we're about to use some place value. It's like assigning each digit a special role. Think of them as the crew members on our multiplication adventure, each doing their part. Uh-oh, looks like we've stumbled upon some mischievous math pirates. I see one walking over there. They've hidden our multiplication problems in barrels, or maybe those plants. But fear not, brave mathematicians. We'll use our area models and place value to outsmart them. Ah, there's some now. I think we can tell them, we can defeat them with a joke. Why did the math book look sad? Because it had too many problems. But don't worry, we've got our math superhero capes on, so let's conquer those problems now. So let's talk about our essential question. We're really wondering, what is a common way to record multiplication? So today we're going to be looking at two ways. One is using an area model and partial products, and two is our standard algorithm, really the way that we've been doing it in class. So let's picture a ferry, the Cape May Ferry, carrying 37 cars per trip on the weekend. If the ferry made 11 trips on Saturday, and it made 13 trips on Sunday, how many cars did it carry on the weekend? Now this 37 is 37 cars per trip. And this 11 and 13 is the number of trips. So the whole weekend, first, we want to add these together. So 11 on Saturday plus the 13 on Sunday. We know that the ferry made a total of 24 trips. We also know that each of those trips had 37 cars. So you can add the 24, or you can add to find the 24 trips were made on Saturday and Sunday. So the ferry carried 37 times 24 trips. So first, we're going to use partial products. Everyone should be taking notes in their notebook right now. And we want to use an area model to find the partial products for 37 times 24. So I need everybody to draw a rectangle right now. And then inside your rectangle, we are going to draw another rectangle. And just like this. So make yours look like mine. Okay, over here, we're going to put 20. And where do we get this 20 from? Everybody look at this problem here and think about where I would get this 20 from. Well, if you said the tens place in 24, you'd be correct. So this 2 in the tens place, remember, that's not worth 2, it's worth 20. And we're going to put 30 up here, which is the 3 and 37, because that's worth 30. Actually, I should have started up here. So, because we have the number 37, right? So we want to expand 37. And the way we do that is 30 and 7. And then down here on the left side, we're going to do 20 and 4. So we're going to expand those two numbers. Now, inside this box here, we want the area of this box here. Now our formula for area is length times width. So we want to do 20 times 30 to get the area of this box. And we know from our previous lesson that when we're multiplying numbers that end in zeros, we can take each of those zeros and drop them into our product. And that leaves us with 2 times 3, which is 6, so it is 300. So that is our first partial product, 600, 600. Okay, down here for this rectangle, we still want to do length times width, so we can do 4 times 30. 4 times 30, we have a 0, so we can put the 0 in our answer, and then 3 times 4 is 12. So that partial product is 120. What about this rectangle here? Well, we got 7 on this side, and this side is, well, we got to jump all the way over here to know that this equals 20, so this equals 20. So this we have 20 times 7 would be the area here. And 2 times 7 is 14. And the 0 is going to go into our product, giving us 140. So that is our next partial product. Is there any more? Can you find another spot for a partial product? If you said down here, you are correct. So we're going to do 4 times 7. 4 times 7 is 28. That's our next partial product. We're going to add all of these together, and when we do, you should get 888, which means the ferry carried 888 cars on the weekend. And hopefully no more of those pirates. So next we're going to look at the standard algorithm. So everybody write standard algorithm in your notebook. An algorithm is just a way of solving the math problem. So we got pretty much 2 steps. Step 1, we multiply by the ones. Step 2, we multiply by the tens. So if we have 37 times 24, we want to multiply using this 4 first, right? So we go 4 times 7, and then we'll do 4 times 3. 4 times 7, and then 4 times 3. 4 times 7 is 28. We carry the 2. 4 times 3 is 12, and then we add 2, which is 14. So we get 148. Now we are finished with the 4. So we need our placeholder here. We're going to place the placeholder down there, and now we can multiply by the tens. And we do that with 2 times 7 and 2 times 3. Now remember, this really isn't a 2, it's actually 20. But because we have our 0 placeholder down here, we can save that time and do 2 times 7 is 14. We put the 4 here, we carry the 1. 2 times 3 is 6, plus 1 is 7. When we add these together, we also get our 888. So what are ways you could estimate to check that this answer was reasonable? Well, what could we do with 37 to estimate? I think 40 would be a great number. And what can we do with 24 to estimate? Well, 24, we could do 25, but mentally 40 times 25 seems a little more challenging, so we could probably just go to 20. And remember, if we realize that this might be a little bit of an underestimate because we're going from 24 to 20, but that's okay. If we multiply these two, we got the 2 zeros, which we can drop down into our answer. And then 2 times 4 is 8. So 800, this looks pretty reasonable to me. Now, if we got an answer like 88 or 88.8 or 8,888, that's when we would know that we did something wrong and it wasn't reasonable. So I want you to keep in mind that if you like this area model and you're feeling really good about it and you're like, oh, I like how I can break it down and see how everything works, use the area model. If you prefer the standard algorithm and you're very comfortable with multiplying by the ones place, then multiplying by the tens place, regrouping, placeholder, and all that good stuff, use the standard algorithm. It is your choice. So we're just exposing you to different methods. When we start the independent practice, however, you are going to have to do a little bit of both. So I just want to try one more quick area model with you. So the problem is going to be 41 times 23. So write this in your notebook. And let's look at 41 first. Let's break that up. What is 41? Well, 41 is 40 and 1. And what is 23? 23 is a 20 and a 3. Like that. This big box here is going to be 40 times 20. Over here is going to be 20 times 1. Down here is going to be 3 times 1. And right here is going to be 40 times 3. Now, if you're looking at this and you have no idea how I just came up with those problems, remember, it's an area model. And the formula for area is length times width. One side times another side that is connected. So the reason this is in here is because this side is the length or width, and this side is the length or width. If you're looking down at this box all the way down here, and you're wondering how we got 3 times 1, well, it's because if we think about what, let me get a color here, this side is, what's the length of that side? Well, there's no number there, but we can actually look and see that from here to here is 3, and from here to here is the same distance as here to here. So we know that side is 3, and we know this side is the same as this side, so this side must also be 1. And because we're doing the area model, area equals length times width, so area equals 3 times 1. All right, final practice one real quick. We're going to do standard algorithm here. Write this in your notebook, 53 times 17. Let's think about our steps. First, we're going to multiply the ones place out, which means we're going to take the 7 and we're going to do 7 times 3, which is 21. Put the 1 here. We're going to carry the 2 to the tens place, but that's going to be a +2 when we get there. We are still focused on the 7. So now the 7's going to go to the next digit. 7 times 5 is 35, plus the 2, don't forget to add the 2, is 37. We can write that down here. Now we are finished with this 7. So that's when the placeholder comes in. Now our focus is on the 1. We're going to distribute the 1 to the 3 and to the 5. So first, 1 times 3 is 3. 1 times 5 is 5. Now, do we add 2 to this 5? No. That 2 is old. I should have crossed it off when we were done with it, because that was from distributing the 7. Then we're going to add. Does anyone know what these 2 lines of numbers are called? Do you know now? 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 I hope you know now. Please know now. Please, please know now. Please, please, please know now. Partial products. All right, we're going to add the 2 partial products. 1 plus 0 is 1. 7 plus 3 is 10. We put the 0, we carry the 1. 5 plus 3 is 8, plus 1 is 9. Now let's check it using estimation. 53 is close to 50. 17 is close to 20. I got 0, 0. If I multiply these guys, we get 0, 0. 2 times 5 is 10, which gives us 1,000. That seems pretty reasonable if our answer is 901. All right, I think we are ready to defeat those Buccaneers with our math skills. You conquered multiplication mayhem on the Cape May Ferry. Keep those area models and place value tricks up your sleeve. Until our next adventure, may your math be merry and multiplying.